Okay, we want to continue with drawing our shear and bending moment diagrams and with equations. So we have our trapezoid shaped distributed load. We have 6 kips per foot here, 18 kips per foot there. And what we need to do is to find the reactions at our supports. And so let's break up this trapezoid. The way we're going to break up the trapezoid is with a rectangle and a triangle. And just go to this next page. What do we have? I've got 18 kips per foot on the right. I have 6 kips per foot on the left. So my rectangle here will be 6 times 5. So the area of my rectangle is 6 times 5 is 30 kips. My triangle then, since this is 18 and this is 6, that means this is 12. And so I'm going to have a height of 12, a base of 5, and then my area is going to be 1/2 12 times 5, which is 30 kips also. And to get the location for the triangle, so we have to locate this, right, using the 1/3 2/3 rule. So here's my 5. I use 2/3 of 5 on the left side. I use 1/3 of 5 on the right side. So I can locate my load for the purposes of getting my reaction. So that's 3.33 feet. That's 1.67 feet. So when I go to do my reactions, I put in, I guess I haven't shown it here, but what do I have? I have one load here. The 30 kips for the triangle is going to be there. The 30 kips for the rectangle is going to be in the center there. So I know that this distance is 1.67. I'm going to let you can work this out. I'm not going to go through this in detail. But the calculations of getting the reactions, taking the moments about A is there. You can pause the video. Taking the moments about B is there, and you can get those reactions. So we get AY is 24.5, we get BY is 35.5. And now I want to use this free body diagram to draw my shear diagram and my moment diagram. So what do? I start at 0, I go up 24.5 over. I know that this total load is what? It's 30 plus 30 is 60. So I am going to I need to go down 60 from there. So I'm going to go down 60, which is going to take me to negative 35.5. How do I get there? Well, it's going to be a curve, and I know that, so that value there is 18, this value there is 6, so I'm going to have a slope of, it's hard to draw, a slope of negative 6 there, and a slope of negative 18 there, so there's only one way to draw it, and it's approximately like that. It's not perfect, but for the sake of sketching it in, that'll work. And then I go over and then up back to 0. I want to get my areas, as we notice that there are no concentrated moments here, so the areas are going to give me my moments. So I have area 1, area 2, area 3, area 4, and of course area 1 is easy to get, area 4 is easy to get, but area 2 and 3 not so easy. So I can work this in both directions. I start at 0. You can all get these areas. That's 73.5. So I go up to 73.5 on this side. this area is negative 71. That means I have to be at 71 there because I'm going to go down to 0. So I get the 73.5, I get the 71. Now, what else, what do I have to do? Well then, what do I know? I'm over here at 73.5. That is a positive area, so I'm going to be going up. I hit a slope. My slope there is 0. Why? Because the value of my shear is 0. And then area 3 is negative, so I'm going to be going down. So I know the shape of my moment diagram. I know that it's going to look like this. But I don't know at this stage, I don't know the value of that point. I just know that it's above these other 2 points. So we will figure out this value, and I'll show you how to get it. So what do? We write equations. We're going to write an equation for this line, and then we're going to integrate it, and so that's what we're going to do. So let's just take it. Okay, well, if I look at, I want to write the equation of this line. Well, if I look at it with my coordinate system being here, so there's my x, there's my y. Given that coordinate system, this point has the coordinates of 3, 6. This point has the coordinates of 8, 18. That's what we're going to use for our, to create our line equation. And you can all do this, but I'm going to review it one more time. So I have 3, 6, I have 8, 18, 2 points. You write the equation of that straight line. And you all know how to do it. M is delta y over x, 18 minus 6 over 8 minus 3. So I get my m is 2.4. Y is equal to mx plus b. That means I have y is equal to 2.4x plus b. And then I could use 3, 6, I could use 8, 18. It doesn't matter. But I have to take and put those values, or those values, into that equation. So I've chosen, for these purposes, to use 3, 6. So I put in y equals 6, x equals 3. I solve for b. I get b is equal to negative 1.2. So the equation of that line is y is equal to 2.4x minus 1.2. You can check it. I can plug in 818 into that equation, and just to double check it, and I get that is correct. That's plugging everything in. I get that 18 equals 18. So now what we're going to do, so there is my expression for Q, basically, and I have to integrate the negative of this. Why do I do that? Because that's, according to our derivation, we have to take the integral of the negative. So I just put in a negative sign up here. That becomes positive. So I'm integrating negative 2.4x plus 1.2 dx. And you can all integrate that polynomial. I get that, and then I put on C1 plus C1. And then that gives me my, what does that give me? That gives me my V equation. Then to get my M equation, what do? I integrate it again. And so again, I have a polynomial. You can all do that integration. But then I have plus C1x plus C2. So that gives me the equations for my V and M diagrams. I just have to find out what the C1s and the C2s are. So in other words, there's our equation for Q, which we just developed. There's our equation for V, which we just developed. It's C1, and there's our equation for M that we just developed. So now what we need to do is to get C1, whoops, to get C1, I'm going to look at the shear diagram. And what do I find? I look at the shear diagram, and I have to do it in this region here. In other words, I have to do it in here. I can't do it out here. That's no good. I have to do it within this region here. So I see that at x equals 3, V is 24.5. So I simply put in those values into my V equation, and I solve that for C1. I get C1 is equal to 31.7. So the equation for V is this. Now what do? Now I know what C1 is, so for my M equation, I simply put that in. C1x is there. And to get C2, I look at the moment diagram. Again, I look at the moment diagram in this region here. And what do I see? At x equals 3, M equals 73.5. So I put in at x equals 3, M equals 73.5 into my moment equation. And plug that in. I solve for C2. I get C2 is equal to negative 16.2. And that becomes my equation for the moment diagram in this region. So that gives me that equation of that curve there. So I now, what I want to do is I really want to get that value there. And how do I get that value? Well, I note that V equals 0 at this distance x. So I want to get this distance x. So I look at my equation for V. I'm going to set V equal to 0. And I'm going to solve for x. You've done this a long time ago, so. So what do I have? Here's my V equation. I set it to 0, and what do I have? I've got the quadratic equation here. You need to be able to solve this. You can use your calculator. You can do it by hand, however you want to do it. But we know that, the basic quadratic formula is this. X equals minus b plus or minus the square root of b squared minus 4ac over 2a, all over 2a. I can plug everything in, and I get that, I get that x is equal to 5.67. I get two answers, but the other one is outside my range. So I get x equals 5.67. What do I do with that? I put that into my moment equation, and so I just plug that value of x, and here it is, and I end up with m equals 109.91 kip feet, and that gives me that value right there. And now I know what my M max is, which is an important value. So you need to be able to do this. We get our M max, okay. All right, so this is a similar problem. Find the reactions, draw the shear and bending moment diagrams, and write the equations for Q, V, and M in the range. In this range, which is the range of x between 1 and 4. So what I want you to do, and find M max, I want you to pause the video and do this one. Okay, I'm assuming that you've paused it and you've done it. I'm not going to go, well, okay. So what do we have? It's a trapezoid, so I break it up into rectangle and triangle. And the area of my rectangle, this is 5, this is 11. So you can all do this, but the area of the rectangle then is 5 times 3. The area of the triangle is 1/2 3 times 6. And so that's 15 kips, that's 9 kips. I can put them onto my free body diagram here. I use the 1/3, 2/3 rule, so I'm not going to go through that, but you should be able to locate these properly in here. And you should be able to then take this free body diagram, take the sum of the moments about A equals 0, take the sum of the moments about B equals 0, and get the reaction. So I get my reactions AY, or BY, I get AY, and so I can write those in here. I then draw my shear diagram. I go up AY over, then I know this total load is what? 9 plus 15 is 24. So I'm going to go down 24. How do I get there? It looks like that, because over on the right side my slope is -11. On the left side my slope is -5. And then I go straight across and up. So there's my shear diagram. My bending moment diagram, again, what do? I can get areas 1, I can get areas 4, 13.25, -21.5. So, I can go up 13.25, and for some reason I'm not showing it here, but this is going to take me to, it's not drawn to scale, but this would take me to there. That would be 21.5, and then I'm going to get some sort of curve that looks something like that there. So we are going to write the expression for the Q. So I need to write the equation of this line here, and you can all write the equation of a straight line given the coordinates of the points. And so, hold on. Oops. So I want the slope of that line. What is it? Well, I've got 11 there, I've got 5 there, so, and then that's 3. So the slope of that line is going to be 11 minus 5 over 3. And that slope is 2. So the equation for Q is going to be 2x plus b, and I note that at x equals 1, q equals 5. That's that point right there. X equals 1, q equals 5. And I plug that in, and I get 5 is equal to 2 times 1 plus b. B equals 3. So my equation is q is equal to 2x plus 3. I then need to integrate the negative of that to get my v. So when okay, there's my 21.5 there, this is like, okay, so we've done that, and my integral for v, I'm going to integrate that. So it's all a polynomial. I move the negative inside, so I get minus x squared minus 3x plus c1. What do? I note that at x equals, so I'm going to take this point over here, which is x equals 1, v equals 13.25. I plug it in, and I solve for c1, and I get c1 is equal to 17.25. And so the expression for v is that. I then am going to integrate that to get my m. Oops. M is going to be that. I have to tack on the c2 at the end. You can all integrate a polynomial, so it's no problem. And now I'm going to look at this point, which is x equals 1, m equals 13.25. I plug that in, and I solve for C2. I get C2 is equal to negative 2.17. And so my expression for m is that. Now what do I want to do? I want to figure out what is this value here to get my m max. Well, I have to set v equal to 0 because v is 0 here. Solve for x. So it's the quadratic equation. 0 is that. You can all solve this. I get x equals 2.92. I then take that 2.92 and what do I do with it? I put it into that. So I get my m max by plugging in that value of x equals 2.92. And I get m max is 27.12 kip feet. So that's that one. Okay, so I'll give you another one here. Find the reactions, write the equation for Q, draw the shear diagram, find the shear equation. I guess I'm not asking for bending moment, but we'll see. So in this particular case, I've given you the points. You can start by writing the equation of that line. So pause the video and do that. Okay, I assume you've done that. And so what do we get here? We get that, let's see, there are different ways you can do it. But, oops. What's this? So you should be able to do this part of it, but what do I know? The slope is negative 4.6. Why? Because it goes down 4. 7 minus 3 is 4, and the x is 6. So, and it's obviously a negative slope. So you check this. Make sure you get a negative slope when you see a line sloping downward like that. So the slope is negative 0.667. And so I know that my q is negative 0.667x plus b. And then I take this point, which is at x equals 2. There's my x equals 2. Q equals 7. So I plug that into my expression for q. I plug 2 and 7 into there. And I get b is equal to 8.334. So my expression for q is that. I'm now going to integrate the, well, okay, I forgot to do the reactions for you, so I'm not going to dwell on it because you should be able to do that. I break it up into a triangle there and a rectangle down here. So triangle and rectangle. For my triangle, you can do that. I get 12 kilonewtons for my rectangle. I get 18 kilonewtons. And then, I use the 1/3, 2/3 rule for the triangle. I use the, center of the rectangle for that one. And like I said, you can then, once you've done that, you can pause the video and figure out how to get the reactions. So once I've done that, then what? I can draw the shear diagram. So I get this reaction here, I get that reaction there, I go up 21 over, and now look what happens. Now I draw a slope of -7, and then over here I draw a shallower slope of -3, so it looks like that. I want to get that curvature right. And so I'm over here, I do that, up, over, straight across, up. So I now have my shear diagram. I want the equation of that line there, that curve. How do I get it? I integrate the negative of this, integrate the negative of the q, so it's this. I integrate it and then make sure that you put on the C1 at the end. And how do I get this C1? Well, I note that at x equals 2, this point, V is 21.375, and I plug that into my shear diagram equation, and I solve for C1. I get that, so my value for the shear equation is that. And what would we do? We would integrate that again to get the moment equation for this one. And to do that, so I guess I'll do that. And so I integrate that. You can all integrate that polynomial. I get this. And then I have to tack on the C2. How do I get the C2? I note that I'm looking at, my moment diagram. Okay, I got to get my areas here for my shears. So I get area 1, area 4. And these are the area 1 and area 4. Those are rectangles, so you can easily get them. So I go up area 1. For area 4, I know I have to be at 69 there because I have to go down negative 69. So my lines, I get that, and then what do I get? Then I get a curve that looks like that in between. I want the equation of that now, and what do I do? Like I say, I integrate we've integrated that, and we tack on the C2. So I point out that at x equals 2, I use this point, m equals 42.75, and I get my C value, which is negative 14.9, so my entire m equation is this. And then what I want to do is I want to get this peak there. How do I get the peak? Well, I want to figure out what that x value is when v equals 0. I set this v equal to 0, this equation equal to 0. I solve the quadratic equation using that formula. I get x equals 5.69. I take that 5.69, what do I do with it? I put it into my moment equation, and I get that m max is 79.5 kilonewton meters. All right, I'll stop there.